Good evening, MOCA friends. My name is Yifan Wu, Director of Programs and Chief of Staff at the Museum of Chinese in America. It is my pleasure to welcome you all to this insightful discussion with Thomas. Oops. Apologies on that. Or continued. It's my pleasure to welcome you to this insightful discussion with Thomas S. Mullaney, Professor of Chinese History at Stanford University and author of The Chinese Computer, A Global History of the Information Age. This event will uncover the fascinating untold story of how the Chinese language overcame unparalleled challenges and revolutionized the world of computing. The conversation will be moderated by Herb Tang, MOCA's curator and director of exhibitions. We also encourage you to submit questions anytime during the discussion for the Q&A. This event is being recorded for on-demand viewing on MOCA's YouTube channel. If you enjoy tonight's program, please consider supporting MOCA. Your generosity is vital to our institution and help us create future programs that inspire and uplift diverse communities. You may donate on our website at mocanyc.org. If you would like to purchase a copy of The Chinese Computer, please explore the options at mitpress.mit.edu, and you can search The Chinese Computer, the title of the book. Without further ado, I will hand it over to Herb to start the conversation. Thank you so much for joining us tonight.
Thanks, Ifan, and welcome everybody. It's great that you're all joining us. It's a really special, exciting talk that you're about to participate in. I first met Thomas Mullaney back in 2018 because I'd heard about an exhibition that he curated at Stanford University at a library at Stanford. And it was all about the history of Chinese typewriters and word processing. And it was such a fascinating set of stories that intersected, technological history with linguistics and these really interesting kind of quirky personal stories of people who are trying to solve a very complex problem of how to make machines that could, type out the Chinese character. And he's able to tell these stories in such a accessible way that also didn't sacrifice the rigor of the research. Through his exhibition and his book of the same title, Chinese Typewriter. And now he's back with a kind of follow-up to Chinese Typewriter with a book about Chinese computing. And, I'm going to be really curious to hear about the differences in, both of these projects and the overlaps as well. So, yeah, without further delay, I'm going to welcome Thomas to the floor. And then after Thomas gives a talk and presentation, then we'll take questions from you all, the audience. So definitely, as you're going through it, please think of some great questions for Thomas, and I'll have some ready as well. All right, Thomas, take it away.
Well, thank you so much. Can everyone hear me okay? Is it coming through? All right. This is a very, very special occasion for me. I always appreciate the opportunity to talk about this work, but this is a homecoming or reunion of sorts. Once I start the presentation, I'll show you images to tell you what I mean, but to reconnect here with Herb and to meet new colleagues at MOCA is a true pleasure. I'm going to share some images because I found that it is very, very difficult to understand what a Chinese computer looks and behaves like, or a Chinese typewriter without imagery. I'm going to try to make my remarks somewhat brief because I really would love for most of our time together to be driven by questions. So just to reiterate what Herb just said, please do just add questions to the Q&A just as soon as they come to your mind, and then of course we'll address them at the end. But I for one have a very poor short-term memory, so please go ahead and share them right away. Let me go ahead and share the images and make sure those are coming through. It appears to be coming through okay. So this is a homecoming almost 6 years to the day of the opening of the exhibition that I guess curated at MOCA in 2018, a very different time, but it opened on October 18th, Radical Machines, Chinese in the Information Age. And I cannot exaggerate that this has been just a highlight of my career in life to work with the team at MOCA and to see this thing come to life. So whenever I look at these photographs, I get emotional because it's just it is the first exhibition globally of its kind to explain and narrate and in some sense celebrate this long forgotten history of modern Chinese information technology. And I'm grateful to this day that MOCA saw in it that possibility and then just made it just truly something that I'll bring to the grave. Today, I'm talking about The Chinese Computer, the book on the right. As Herb mentioned, this lives in concert with my first book called The Chinese Typewriter, A History. Both of them are on MIT Press. The full span of these two books run from the mid-1800s all the way to the present. And I can explain the problem that these books address very, very simply, which is everyone that is porting in today over Zoom is sitting in front of a laptop, a desktop. In front of you is a QWERTY keyboard, most likely. And I'm looking at my MacBook Pro. What are there? Maybe there's 26 letters, but then there's maybe 50 keys in all. That's enough for the English language, for the Latin alphabet. That's enough for French. That's enough for German. That's enough for, if we switch the letters around, Cyrillic, Russian. But Chinese is, as I'm sure most in the audience know, a non-alphabetic writing system. It is character-based, and just for the sake of simplicity, let's say that there are 100,000 of these characters. And so if we were to use the QWERTY keyboard the way it was meant by engineers back in the 19th century building typewriters, where one key equals one symbol, where what you type is what you get, then you would need a keyboard the size of my entire office at Stanford to fit all of those characters. And so the question became, how do you take the Chinese writing system, this character-based system, and fit it inside all of these game-changing technologies, the electric telegraphy, Morse code? How do you fit Chinese in Morse code? Typewriting, hot metal composing in terms of linotype, and then all the way up until computing. And there's many other technologies that I haven't mentioned. All of those technologies, out of the accidents of global history, were designed with the English language in mind and only later extended to other languages, other writing systems on Earth. And so that's really the problem. I follow the people, the engineers, the linguists, the entrepreneurs, the sort of eccentrics who were fascinated by this puzzle, this engineering and linguistic puzzle, and dedicated pretty much their entire lives and careers to this question. And so those are the cast of characters I follow across these two books. But I'm going to focus mainly on the second of these books with some important back reference to the Chinese typewriter. I'm going to start here, and I start in the book with a typing competition. So this is a typing competition from 2013 in Henan, in mainland China. And if you've ever seen a typing competition, it's exactly what you imagine. It's a bunch of people in front of their, in this case, computers, and they all have the same document that they need to copy. And whoever can copy it fastest and most accurately wins the title, okay? In a moment, I'm going to ask you how fast you think the winner of this competition got. How many Chinese characters per minute do you think they achieved, the person who won this? But before I ask you to guess and maybe throw it maybe in the chat, if that functionality is permitted, but you can, if not, then throw it in the Q&A. I want to just briefly explain how Chinese computing works. I'm not going to keep that a mystery. The first thing you'll notice is that everyone in this picture has like a Windows machine. This is like a Dell, an off-the-shelf. You could buy it at Office Depot. There's nothing fancy, nothing special, nothing specifically Chinese about these machines. And yet, and you can't quite see it in these images, all of these contestants have a QWERTY keyboard in front of them, just like the one chances are you have in front of you right now. And so somehow 100,000 Chinese characters have been made to fit on this space. How does that happen? This is an actual screencast recorded from the contestant who won the competition. So I'm going to show you, I'm going to play it maybe once or twice, and I'm going to narrate just what are the key features of Chinese computing so that you understand. The first thing is, in this particular computer screen, the top of the screen that starts off with the character Su, this is the text that all of the contestants have to copy. If you read Chinese, you'll know that this is gibberish. This is part of the competition that was the random character part of the competition. Basically, it's the part of the contest where everyone is entering one character at a time. Okay. On the bottom, the part that's blank now, that's the composition window. Very soon, you're going to see Chinese characters beginning to appear in that window. Let me go ahead and press play, and I'll explain what's going on. Okay. So the first thing you'll notice is that what this person is actually pressing on their keyboard are not Chinese characters. They are letters of the Latin alphabet. L, H, J, P, E, Y, M, H, W, C, K. So that's what this person is actually typing. The first premise of Chinese computing is no one actually types Chinese. Everyone enters either Latin alphabetic characters on a QWERTY keyboard or maybe strokes on a trackpad. The second key feature of Chinese computing is this pop-up menu, this rectangle that is anxiously following the user and presenting different Chinese characters, 1 through 9, based upon the letters that, in this case, he is entering. So you notice there's the characters in the list are changing over time. Now, what is going on? Many of you will already know the answer to this, but just to summarize, is that there is a special computer program called an input method editor, in Chinese, a 输入法. And this is a program that runs in between the user and whatever computer program they're using, Microsoft Word, email, in this case, this competition software. And every time the person touches a key, the computer, this IME, input method editor, grabs the letter that the person has entered and uses it to try to answer a basic question. What Chinese character does the user want based upon the data they're giving me? Okay. And so the person is typing these letters, not so that these letters will appear on the screen, but almost as instructions or criteria for the computer application to try to figure out what Chinese character or characters does this individual want. And so that's what the 1 through 9 is doing. The person enters these things, and the computer program is saying, do you want this, 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 or this? You've entered another letter. Let me give you more suggestions, more suggestions. And the second that he sees the character or characters that he's actually wants to see on the computer screen, then the user can simply type 1, 2, 3, 4, 5, 6, 7, 8, 9 to choose, or just the enter key or the space bar. As soon as the user selects which character they actually want, the pop-up menu goes blank, and the process begins again for the next character or series of characters. So it's a circular process in all Chinese computing, where the user is not what you type is what you get typing, but is providing criteria to the input method system. The input method system, or the input method editor, is providing candidates, that is, possible matches, Chinese character matches for what the user entered. And then the user is doing one last step of confirming which character they actually want. So this like feedback loop that goes through. So it is very different than English language or French language typing, where you just write, the cat bit the dog, where what you type is what you get. So there are extra steps to the process. Now I'm going to ask, we have one person who has already made a bold guess of 250 characters per minute. How many characters per minute do you think the winner of this competition actually achieved? 50, 120? Just what do you think was the top speed in this competition in 2013, especially given all of these extra steps that all Chinese computer users have to use? I'm very curious. We have some very shy people. That's okay. 175. All right. 250 before that. 700. Very bold. All right. Anyone want to go high? Does anyone think it's 1,000,000 characters per minute? This is very confident. I like it. All right. The answer to this question is 221.9 Chinese characters per minute, which is the equivalent of 3.7 Chinese characters every single second. Now, a Chinese character and an English word are not the same thing. It's not a one-to-one correspondence. There are some Chinese characters that are the equivalent of an English language word, but in most cases in modern Chinese, an English language word is the equivalent of a Chinese ci, a two-character compound. So it's not a one-to-one correspondence, but however you calculate the ratio of characters, Chinese characters to English words, this is far faster than the top speed in English typing, the Guinness Book of World Records, let's say. This blows out of the water the top speed in English. So this is to say that when someone is sitting at their MacBook Pro typing in English, however fast they are, and this particular man standing in Henan in mainland China going as fast as he can, he will always be faster than his counterpart operating in English. How is this possible given all of the extra steps that are there within Chinese computing? So I'm going to give you two kind of separate passages here from 1989. This is sort of a midpoint of the history of Chinese computing to contrast this. We have a Chinese engineer, computer scientist, Zhang Guofang, who's talking in 1989 of that as technology advances, we have every hope that users, that is using Chinese 输入法, input method editors, with leisurely keystrokes will be able to reach or greatly outpace the speed of human speech. So it's a very confident statement about the future of Chinese human-computer interaction and input. Contrast this with a quote in the very same year by John DeFrancis, considered basically the father of modern Chinese linguistics in the Anglophone world. He is the person that trained all the great linguists in the latter half of the 20th century, who came up with the exact opposite diagnosis in 1989. Basically, there will never, ever be a Chinese input system as efficient as what you type is what you get, English. So at the end of this is not to criticize the memory of John DeFrancis, but he was completely wrong. He was utterly wrong on this account, and his counterpart was right. How is it that Chinese computing overcame this profound challenge, not just to reach parity with the Latin alphabetic world, but actually to surpass it? That's what we're going to talk about. So there's four parts of this for the brief presentation. And each of these parts, the zi, the ci, the ju, the wen, the character compound sentence writing, each of these are almost like mini era in the history of Chinese computing. And you could define each of these era by the main challenge that had to be overcome in that particular time. So the very first challenge was, how do we get even one Chinese character into a digital space? That was not a self-evident question. So how do we overcome that obstacle? But then once we solve that problem, how do we get two-character Chinese compounds into digital space? And once we solve that problem, how do we get long text strings of Chinese characters into digital space? And then the era we're living right now is effectively generative AI. I'm going to make the argument by the end of this brief comment that Chinese computing has in some sense been experimenting with the precursors of generative AI, that is ChatGPT and so forth, decades before their counterparts in other writing sort of traditions in the digital age. So the first era, and that's how it goes, the zi to the ci, the ju to the wen, that's how we're going to proceed. All right, the first challenge is just very simple, but also very profound. How do we get even one Chinese character into the digital realm? And this is a problem that predates computing. So as I talked about at the very beginning of this presentation, the problem of how you fit 100,000 characters into an information technology is not a computer question. In fact, the first technology that was a major problem for was in electric telegraphy, in Morse code. How do you make a code system that allows you to use like dots and dash to transmit one of 100,000 characters? That's not a simple problem to overcome, but it becomes exacerbated in the history of typewriting. And this is of course the history I address in my previous book. But the question of how one fits the Chinese writing system onto this newfangled device called the typewriter, that is a post-United States Civil War precision technology that, of course, takes over the world in the first half of the 20th century. To be modern is to have a typewriter for your language. And so how do you do this? Well, again, if you were to use a Remington typewriter or an Olivetti typewriter, where if I depress the key marked H or J or U, I expect that letter to appear on the piece of paper. If I use that logic, then I would need a typewriter the size of a building in order to handle Chinese. So in other words, the sort of logic, the technological logic of the typewriter built for the English language was not compatible with the necessities and the needs of Chinese. So what do we do? In the case of this era of Chinese information technology, effectively China created or carved out a sort of separate road in the broader history of modern Chinese information technology. In short, this is a Chinese typewriter. Engineers created a typewriter with no keys, a typewriter with no keyboard. And if that sounds like an oxymoron, it isn't. There actually were many keyboardless typewriters at the very, very early history of even English language typing, but those died out and were replaced by the keyboard-based system. What you're looking at here is a Chinese typewriter, and let me just introduce it quite briefly. I'm not sure if you'll be able to see my cursor. I think you can. Oops, I don't want to go back there. In the middle of the screen, you'll see a kind of green knob. Let me see if I can go to that without, yeah, I think you can see my cursor. A green knob. With your left hand, you would be able to move that green knob left and right. And that entire rectangular shiny area would move left and right. That shiny rectangular area contains up to 2,450 Chinese characters in small metal slugs. And these metal slugs are loose. If you take this machine and turn it over, all of those Chinese characters will fall out of the machine. With your other hand, your right hand, you would hold on to the knob, this other green knob towards the top of the machine. And that would allow you to move the entire platen holding the paper front and back, left and right. And the goal of this was to get this tiny rectangular metal chamber over top of whichever Chinese character you wanted. Then you would push down on your right hand, a little metal finger would push that metal slug up, lock it into the chamber. It would then shoot up on an arm that rubs past this ink to get it covered in black ink. It would strike the surface of the paper. There's no paper on this machine here. And then the arm would fall back down, and the momentum of that would spit the metal slug back out into the hole that was left behind. That's what Chinese typewriting was. And so you're not using your 10 fingers, you're moving around this space. There were schools for this. There was a labor force for this. There were publications and typing manuals. And the way that you studied how to use this machine was very different than using a Remington. You would practice various compounds. So it was organized according to the dictionary, the Chinese dictionary. And so characters that went together were not near each other. So you would practice, xue sheng, student. You might practice hui yuan. And you would get good at remembering the relative location of about 2,500 characters. Now, 2,500 is a lot of characters, but it's not 100,000. So what's the deal? The answer is that we can't fit all 100, we can't fit the entire Chinese language onto this device. So we're just going to include the most statistically frequent characters out of all. There's some interesting stuff we can talk about it. Now, where this brings us to the era of Chinese computing is in this 1947 experimental Chinese typewriter released by the famous Lin Yutang in 1947. You are looking at a Chinese typewriter, mechanical. This is not a computer, but it's a Chinese typewriter with a keyboard. And you might think, you just told me there can be no Chinese typewriter that has a keyboard. Why are you lying to me? Why did I sign up for this webinar? And the answer is this. This keyboard does not behave the way that any keyboard in the history of typewriting ever behaved. If you were to sit down at this and push a key on one of these machines, you would hear gears moving inside the machine, but no Chinese characters would appear on the paper. You might think it's broken and try again. You push another key. You hear more gears moving, but again, no characters have been printed on the paper. But after those two keystrokes, something would happen, which is that up in this like rectangular little glass window, up to 8 Chinese characters would appear that fulfill the criteria you provided thanks to those two keystrokes. And then your third and final keystroke would be the number 1, 2, 3, 4, 5, 6, 7, or 8. You are looking at the very first shurufa in history, and it came before the computer. This is an input method editor built out of metal. And the idea here is that we're going to sever, we're going to cut the relationship between the keyboard input and the printed page output. We don't have a one-to-one relationship anymore. And so we can have a small number of keys, but an incredibly large number of characters. The image on the right is effectively a metal hard drive that is inside the chassis of the machine out of sight. And it was like octagonal metal bars containing Chinese characters, them packed into this really tight space. Think of Ferris wheels inside Ferris wheels inside Ferris wheels, all of which can rotate. That's where the characters are stored. And then you're using the keyboard to retrieve those characters almost like from memory. But this is not a computer. This machine is never mass manufactured. There's lots of geopolitical reasons, the Civil War in China, the revolution in 1949, the Cold War, lots of different reasons why this never sees the light of day. But the principle of this machine lives on. That glass window is the world's first pop-up menu. It's not software. There's no computer monitor, but it is a pop-up menu. Its job is to help the user confirm which character they want and to select it. The pop-up menu has been part of Chinese computing since this moment, and since the very first Chinese computer, which you're looking at right now, the Sinotype, or the ideographic encoder from 1959, developed at MIT by a professor of electrical engineering there. What you'll see is a keyboard, very small number of keys. They're actually strokes of characters, but very small number of keys, and then a database of characters inside the machine. In this case, it's not metal, it's a photographic type database. And what you're using the keyboard to do is to retrieve things from memory. And lo and behold, right here is the world's second pop-up menu. This little image right here is a device meant to confirm for the user that, yes, that is the character I want from my input sequence. Pop-up menus have been part of Chinese computing since day one. This is one of my favorite examples from 1972 in Shanghai, where there literally were two monitors, the composition monitor and then the input method monitor. And then eventually these two things were merged into a single computer monitor the way that we experience it now, with a composition window on the top and then an input method editor, shurufa, a pop-up menu somewhere else on the screen. This is the world's first implementation of Chinese text processing on a Mac, on a Macintosh, an Apple, excuse me. So by this point, by say the 1970s, if not by the 1960s, we've solved the problem of getting one character in. But one character at a time is really, really slow. No one's going to win the Guinness Book of World Records doing it this way. It works, but it's slow. But here's the thing, is that, like I said before, modern Chinese is not made out of one character at a time meaning. Most words in Chinese are built out of two characters. Think of 学生, student, right? That's not one character, that's two. Is there a way for us to exploit engineers' thought and linguists' thought and entrepreneurs' thought, that feature of the Chinese language? And the answer is yes. So now the goal is, let's not worry exclusively about inputting one character at a time. Can we input multiple characters at a time? I'm going to, so this is the second era of it. I'm going to sort of jump right to this so we can get to the discussion. This is a drawing of a computer monitor from the 1980s. Very important, the date, 1980s in China. And what you'll see is the similar thing. You'll see, for any Chinese speakers, 中华人民共和国, People's Republic of China. So this is the composition window. Someone is typing this, right? What it means is that and then you have the input pop-up menu on the bottom. Now this user has just typed in the character guo, right? So guo means country. Notice that the pop-up menu is sort of blank, but then there's these two extra pop-up menus on the bottom. One of them right here on this row is called the lianxiang zi, and there's 0, 1, 2, 3, all the way 0 through 9. And then there's this thing called the lianxiang ciju with A through J. The idea here, and for those of you who don't read Chinese, don't worry about it. The idea here is that the input method editor isn't going to just wait for the user to give them information in order to try to figure out what the user wants. Now, in addition to doing that, what I, the computer, am going to do is say, what was the very last character that the user entered? And based on that, what is the next most likely character that they may want? Let me offer those right now before they've touched a key. Let me offer the user those options right now so that if I get it right, the computer is saying, then the user doesn't even have to enter a new input sequence. They can simply select 0 or 3 or 7 or 9, because 0, for example, is jia. So 国家 is country. Number one, 国防, national defense, 国际, international, 国内, domestic, 国外, foreign. And then you have even 3 character compounds. Now, this is still rudimentary. For any Chinese speakers, you'll know that it doesn't make sense to say 中华人民共和国防. So it's still rudimentary, but it is already very, very sophisticated in trying to anticipate what the very next feature is. Now, for anyone here who may have come to the exhibition at MOCA or knows this innovation is not a computer innovation either. It also dates back to the era of mechanical Chinese typing. I'll give this in a nutshell version, but as I mentioned, those 2,500 characters on the tray bed are organized in dictionary order. And think of English. So apple is next to aardvark in the dictionary, but those two words don't go together. Apple and pie, like apple pie, are very far apart in the dictionary because dictionaries are never organized according to natural language. They have some sort of rational order. Well, some people, beginning in the 1950s, these were typists in mainland China, and also they were publishers, printers, compositors working in printing houses, said, well, that's kind of silly because every single day I find myself writing the exact same compounds, 学生, 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 or 毛泽东, 毛泽东, over and over and over and over and over again. Why don't I abandon dictionary organization, and why don't I redesign my typewriter tray bed so that words that the characters that go together in real Chinese are actually next to each other in my tray bed? And that's what they did. They dumped out all the characters, and then they started to assemble these natural language arrangements of their tray bed. What's very cool about this is that that means that once you dump out all the characters and start rebuilding it, that means that if any mathematicians in the audience, you'll know that that's 2,450 factorial possibilities, i.e. 2,450 times 2,449 times 2,448. There are more different Chinese typewriter tray beds than there are atoms in the universe. And so everyone who did this had their own answer to the question. This is a tiny sample of one tiny portion of one of these machines that from the era. And if anyone here reads Chinese, you'll know there are a lot of characters that are next to each other that actually go together in real Chinese. 同时,同,共同,同时,时间,时期,随时,随便. And the idea is let's try to get these things adjacent. What you're looking at is the first sustained experiment with what we now call predictive text, trying to anticipate the very next character. Now, on a typewriter, you only have 8 possible spaces next to every character. So you're limited by the physical, constraints of this. Once you enter the digital age, XYZ dimensions get kind of funny. Like this is if you ever study AI and LLMs, they're talking about, multi-trillion dimensional spaces here. In any event, Chinese computer engineers were totally aware of this and stole this idea from typing. I'm going to ask a quiz. I hope someone is confident enough. This term, 联想, connected thought, the 联想字, which is first coined by typists. 联想is the name of one of the most important Chinese computer companies in history. What is the English language name of that company? If anyone knows, I'll leave it in. I'll let you try to guess it in the chat as I move on. All right. So this is how this input method is getting faster and faster. Now, by this point, by the 21st century, this anticipation of the very next thing is getting better and better and better. Say you wanted to write an essay about plagiarism at Yale University, which is rampant. You could use really tight abbreviations, and the input system would know what you're looking for with very, very, very few keystrokes. And so the system is getting better and better at predicting 2-character, even 4-character sequences and words. Exactly. Lenovo is the current name. Excellent. 联想. Very good. That's how important this concept of predictive text is that the founder of 联想named his company after this practice of connected thought. That's how important it was. So by the 1980s and the early 1990s, we've already figured out the puzzle of 2 characters at a time. Now we're moving on to longer passages. And here I'm going to speed up. Into the 2000s, Shurufa entered the cloud. So now the quality of the suggestions by the input method editor are no longer limited to your machine and my machine and the memory that now it's using all of the input sequences of every single computer user who is using cloud input. Think of basically the Google search bar where, depending on what the late breaking news is or what's popular in the news that day, the search bar is making better suggestions for what you might want. Well, that was happening in Chinese input in the 2000s for Microsoft Word and email, not for search and search. Okay, so decades or years at least before this kind of stuff was rolled out commercially in the English language. And so very quickly, very long passages become possible to enter with very few keystrokes. One of my favorite examples, I give this in the book, is that if you open up your Shurufa and you enter XMYJJ, chances are really good that your IME, depending on which one you're using, will successfully predict that you want a stanza from a Tang Dynasty poem, 虾马饮君酒. That's and the back end of this, the libraries of Chinese character names and technical terminology and personal names and so forth. It is not uncommon for a Shurufa to have libraries of Chinese character texts that are millions and millions and millions of data rows long, making the suggestions of the input method editor better and better and better over time. Now, this is the reason why Chinese input can achieve speeds that are faster than English typing. Simply put, is since the word go, all engineers and linguists and entrepreneurs and eccentrics working on the problem of Chinese information technology have been worried about how do we squeeze any bit of speed, any bit of efficiency out of this because our starting point is at such a deficit as compared to Latin alphabetic typing. So there was an appetite, an aggressive appetite for experimentation with auto-completion, predictive text, cloud input, really large language models before the name was invented. The idea is, how can we, and every time the tech got better, like now we have basically what in the 1980s were considered supercomputers on all of our desktops right now. As the tech get more powerful, engineers working on Chinese computing are like, great, how can I harness this computational power more and more and more and more? So in Chinese computing, the power of computing itself has actually been exploited. Compare that with English language typing, and the pattern has been different, which is that as brilliant as Steve Jobs and Wozniak were, their goal was to make the user experience basically like using a beautiful electric typewriter. There was the idea that you would use all of these different computational systems. We don't want that. We want the simplicity of what you type is what you get. And what this means is that Anglophone computing left all of this computational power on the table. And basically, English speakers basically treat the QWERTY keyboard that is in front as effectively like a Remington typewriter from the 19th century, more or less. It's improved, but more or less it is the same kind of machine. Now, I'm going to close with this is the era of ChatGPT. Up until right now, there is a speed limit. In terms of the zi and the ci and the ju. And the speed limit is human will, human intention. I have a character in mind, and I'm trying to get it into the machine, and I need the computer to guess what it is. And now I have a two character, and I have a passage. I have a Tang Dynasty poem already in my mind, and now I want to get it into the machine faster. What happens if we remove that speed limit, where now we want the computer to help us generate text that we do not already have in mind? This is generative AI. And so I'm going to just briefly say, when I saw the release of, commercial ChatGPT last year, I was blown away just like every other human being on the planet. But then I paused for a second and I realized, wait a minute, as an English speaker, this is inviting me to have a completely different relationship with my computer than I'm used to. I am used to entering something and seeing it appear on the screen. I'm not used to kind of giving prompts or instructions to ChatGPT, and then ChatGPT does something with that. And then there are better or worse ways to prompt. And it dawned on me that although, of course, generative AI itself is new, that Chinese computing has been interacting with the precursors of generative AI and with prompt engineering, as it's called, for about 60 years already. Because for 60 years in Chinese computing, what you type is never what you get. And one of the main arenas of competition in Chinese computing is trying to invent a better or more efficient input system in a relationship that is what you type is what you get. So there is this interesting idea that in many parts of the world where computing is a what you type is what you get sort of environment, that's English and French and Italian and German and Russian and even and Hebrew and Cyrillic, that generative AI is actually quite strikingly different than any relationship one would have with a computer. But in Chinese computing, in Japanese computing, in Korean computing, in most of Arabic computing, in South Asian and Southeast Asian computing, it actually is not that big of a leap. The tech is big, but the relationship with the computer is in fact something that many of these language communities have been experimenting with in the realm of computing for decades and decades and decades. All right. I want to just close with one more thank you to MOCA for inviting me. And now I'm just really excited to jump into any questions you might have on your mind.
Thank you, Thomas. Beautiful presentation. Fascinating questions, as always. And let's get to some Q&A. So Ivan Ing asks, how might Shurufa or entering the cloud become a means of thought regulation or control?
Sure. I gave a talk maybe about 8 years ago called How to Spy on 600 Million People, and basically pointed out that technically speaking, every shurufa has contained within it the possibility of interception and surveillance. So because every shurufa is kind of like a miniature telecommunications process. You send a message by typing something, but you're not sending a message to another person. You're sending the message to the computer. The computer is translating it and sending it back to you. Anything that is sent can be intercepted. And I mean, certainly the companies that run these shurufa themselves have a vested interest, at least just from the standpoint of quality control, to maintain data on shurufa, just to simply to do error testing and A/B testing and quality control and so forth. And so what that means is that an earlier idea of radicals or dissidents is that someone actually has to write a manifesto and then physically send it, as a letter or email it in order for an intelligence service to intercept it. Now, technically speaking, certainly if you're using cloud input, even if someone typed out a manifesto and then said, whoa, 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 what am I doing? I'm throwing away my life. Let me go Control-Alt-Delete that. It's too late. That has been transmitted. That itself is an act of transmission. And what's funny is that a year ago, a group of computer scientists pointed out this exact same flaw. And because they're computer scientists, everyone was like, oh my gosh, because historians don't count. But yeah, this is a major issue that's baked into the logic of the shurufa.
And then Wei Bin Han has a question about what's the current impact of AI on Chinese translation?
Let me see. Current impact of AI on I'm assuming machine translation. For machine translation models, I mean, generally speaking, they are trained to a far, far greater extent historically on English language corpora. I mean, even more than other European languages, French and German. And then the training data for even other highly resourced languages like Chinese is considered now. There is a fall off. That said, Chinese machine translation stands heads and shoulders above this very, very, very long tail of, say, 6,000 languages that are considered digitally disadvantaged languages even today, for which there really is very, very little training data to build, successful machine translation models. I mean, I think the biggest thing that's changing or the biggest thing that has changed with Chinese machine translation, which actually was one of the very first languages that researchers on machine translation were worried about. There was English, there was Chinese, there was Russian. This was a Cold War technology, after all. Probably the biggest impact is less AI than the rise of just the Chinese economy and the rise of Chinese corporations that have a vested interest in improving the quantity and quality of the training data for machine translation algorithms and systems. So the quality of Chinese machine translation has been skyrocketing on that account. And then, of course, what AI needs most of all is just an ungodly quantity of parallel corpora. And that is something that is achievable in the Chinese case, as compared with many other languages these days.
Great. Another question just came in. So from Patty Chan, is there a way for those of us who only have a QWERTY keyboard to download an app that will allow us to type Chinese characters, or are we limited to?
You already have it. You already
Yeah.
have now every single computer that is purchased anywhere. I'm talking about Dells and MacBooks and Acers. It doesn't matter. All of them now have Chinese input method editors baked in. And for that matter, Arabic and Devanagari and Korean and Tibetan and so forth already in. All you have to do is go to your settings, effectively your settings menu, and go to what is normally called keyboards or international or language. And then once you open that, you get to choose which of the baked-in input systems already on your machine you would like to activate. And the second you check one of those boxes, a little icon, a little image will appear probably in the top or the bottom bar of your computer that then allows you to switch between English and Chinese. Now, if you're not happy with the ones that are already on your machine, you can just go to Baidu or any number of other companies, Sogo, and just download their input method editor for free, and then install it, or it'll be installed and turned on immediately, and then you'll have that. And so now the interesting part of this is now every computer is a Chinese computer. And so that's part of what the book is about, is how did every computer become a Chinese computer when at the outset of this, no computer was a Chinese computer.
Yeah, thanks, Yifan, for alerting me to the questions in the Q&A window. So I'm gonna get to these two. So Sharon Hom asks, can you map this development narrative to the earlier brouhaha among Wikipedia's community debates about Chinese content on Wikipedia, e.g. the traditional versus simplified Chinese? Also, before generative AI, when you said the machine remembered the last time, and word, sorry, maybe I'm not getting the sentence.
Yeah, no, I think
Yeah, I think you get it, right?
Yeah. I'll start with the remembering question. So before generative AI, and I said that the machine remembered the last character that the user entered and then tried to predict the next one. How did it do this without machine learning? It did it because all of that data was hardwired. So you can think of it like a choose your own adventure novel, where if it goes this way, then it goes this way. So at the outset, it was, again, very rudimentary. The engineers would have had to literally mapped out and then hardwired, if this character comes up, then through statistical analysis that we do offline, that we know, and statistical analysis of Chinese goes back to the 1800s, we know that these are the next 9 most likely characters. And so we will just force the input system to enter those. Now, over time, as the tech gets better and better and better, then it is doing this in a more probabilistic way. But in the beginning, this stuff had to be basically hardwired into it. So these large statistical models that then would be, put into the realm of data. And then over time, it's done computationally or algorithmically. Yeah.
I'm gonna collapse a couple of questions from Jeffrey Tao and Judith Yuan about the Shurufa and how kind of customizable it is, and how much designers of the system were able to steer the writing.
So the beginning of and steer the writing, meaning like the whole thought control question again, or like shaping what people would write with it?
The question is like, which Shurufa tend to give a lot of scope for the designers of the system to steer writing, even thoughts and ideas in a certain direction.
Yeah. Very little steering thoughts and ideas through most of this history. That is really, really, really recent in some sense, but with one important exception that actually predates computing. So if the first Chinese computer, the first thing that could be reasonably called a Chinese computer, it's from 1959. So the late 1950s, 1960s, 1970s, 1980s, and the early 1990s, there were hundreds and hundreds and hundreds of different input systems invented. Almost all of them, and I mean literally almost all of them, were not phonetic. They were all based on using the letters of the Latin alphabet to describe the visual shape of Chinese characters. And so even in that screencast that I showed you all at the beginning, you'll notice, if you were watching fast enough, that he was not just spelling out the pinyin sound of the characters. He was doing some other code. He was using what's called wubi, which is a system that uses the letters of the Latin alphabet, is very widely used and is still used today, and by a minority of users, to describe the physical shape of the Chinese character itself. And so those systems did allow nearly infinite flexibility for their inventors to basically design their input systems however they wanted. They could really they could decide, the question is, how do I map the Latin alphabet onto Chinese characters? In the era of what's called structure-based input systems, there were an infinite number of ways to do that, because literally the inventor themselves could decide on what are the shapes we're using, what features of Chinese characters are we describing. It didn't give the user any ability really to shape the sort of creative processes of writers, with one exception. The one exception, which is something that dates all the way back to the 1800s, to telegraphy and then to typewriting, is this question of common usage. So 100,000 characters, give or take, we don't need to worry about the exact number. There, for the lion's share, throughout the 1800s, the 1900s, and even into the 2000s, there have been almost no information technologies that have contained all of those 100,000 characters. Instead, the dominant paradigm through that 150 years is we only should put the most commonly used characters on the machine. And so that is where some politics can enter into play, because it is the designer of the machine that ultimately has to make the decision of what characters go in the machine and what characters get left out. So on the Chinese typewriter, for example, there's 2,450 characters on the machine. If you talk about character number 2,451, that character is going to be in a separate box of characters called the beiyongzihe, the box of secondarily used characters. And if a user wants to use that, they have to take out a pair of tweezers, get it out of the box, put it onto the machine. And so there is a penalty. There is a penalty to going beyond the realm of the most commonly used. Was that used by the designers to shape in a propagandistic fashion the future of Chinese? By and large, no. They really wanted their machines to be useful for average users. They wanted many people to buy them as possible. But every now and then there is evidence that there is a flavor of that. But even if no one wanted to do that, there is still an objective penalty for going beyond the realm of common usage. And even that's even true in IMEs. If you want an uncommon character, you have to toggle down in the pop-up menu until you find it. Does that steer people towards using more common characters? I think sociologically, one's guess would be yes. But it's not necessarily a malicious intent by the designer all the time.
Maybe we'll have one final question, and I think this one's a good one to end on, from Ivan. Do you have any insight about how the widespread use of shurufa is altering how Chinese children are learning the language, especially because the nature of character recall has shifted dramatically?
Well, yes, it is. It's probably. I mean, now I think you would describe Chinese. Let's say I have an elementary school child. We're a Italian English bilingual family, not Chinese, but so I'm thinking about his education. So he's a first grader. If he's by 6 years old, every mainland Chinese student would have pretty deep exposure to Hanyu Pinyin, the standard phonetic system for, Romanizing Chinese characters in the Latin alphabet, and would have started on the process of learning and writing and recognizing and reading Chinese characters. And I'm not sure when in the schooling system in mainland China and Taiwan and Singapore and the Sinophone world when a child is introduced to shurufa, but you could easily imagine it's right about somewhere around 6 or 7 or 8, however precocious the child is. Let's say it's 8. Let's say it's 7 or 8. That means at the age of 7, there is this interesting sort of tripartite thing going on for all Chinese language learning for Chinese speakers, which is this combination of Chinese characters, pinyin, and shurufa. So it's a really fascinating kind of triad of things, and they're not all exactly the same. It's not as if pinyin and shurufa are one thing. They are all different things. So one phenomenon or outcome that we're seeing from this, and this is how the book starts, the Chinese computer starts, is that there has been from the 2000s or the 2010s onward a kind of moral panic in the Chinese speaking world that everyday people are forgetting how to write characters, the concept of 提笔忘字, to pick up the brush but forget the character, and are worried that this indicates a kind of decline in literacy or erudition or kind of a decline of the language itself. And I understand that. It makes sense. It's objectively true that there are fewer people who know how to write certain characters if you handed them a pen or a pencil. But where I would challenge that is it's using kind of old metrics to measure a new world. That is to say that, yes, there was an era not long ago in which to write was simply to pick up an instrument, a brush, a pen, a pencil, whatever it is, and to literally create the word, the letter, the character that one does. The concept of using something like a 输入法, where you retrieve it from memory, simply didn't exist. But now it does. And in fact, it doesn't just exist. More than 50%, not just in China, but even well beyond China, Korea, Japan, I gave you that long list. More than 50% of computer users globally use their keyboards the way China uses keyboards, not the way that someone in Berlin or in New York City, an English speaker in New York City, uses their keyboard. And so we're living in an era where more people are, in fact, retrieve writing or search writing or recovering something from memory than are composing it by hand. So the era itself of writing has changed. And I argue in the book that we are in the opening years, the opening 50 years of an entirely new epoch in the history of writing, dating all the way back to the beginning of writing. And just like the first 50 years of the Gutenberg era, the incunabula period as it's known, we don't yet have the terminology, the vocabulary, the conceptual framework for understanding the era that we are the first generation or maybe the second generation inside. And so we're clinging to models that made a lot of sense not long ago, even from our own childhoods, and applying them to a world where they may no longer fit. And so in the book, I try to offer maybe a map of the terrain, a guide to this new era, not just of Chinese writing in the digital age, but in my argument, writing itself in the 21st centuries and onward.
Thank you so much, Thomas. Again, fascinating presentation, and appreciate answering all these questions. So yeah, a lot of great interaction from the audience, and so thanks everybody for joining us and participating in the discussion. It has been recorded, so which is great. So I think we're gonna post it, and you'll be able to watch it again if you want to. Thomas, thanks again.
Thank you so much.
Look out for the book. Yeah, and look out for the book, everybody. MIT Press. Thanks, everybody. Have a good night.
Have a good night.